Hey guys, welcome back to my channel, and today's problem is maximum sum circular subarray. Uh, it is number 918 from the Leetcode, and you can see this problem in Make Lit Coding Challenge as well. And this problem is really similar with getting maximum sum subarray, but the difference is the array is given the circular array. All right. Before we find out what the circular array is, let's start with the normal array. We're given normal array length 6 in here, and the subarray is contiguous elements of array in this array. For example, this -1 and 5, -3, and those elements, this array has contiguous elements in this normal array, so this is called subarray. So, what is the circular array? As the same elements with this, I can draw the circular array like this. So, circular array means even if the end of the elements is 1, it is connected with the first element in the normal array. So before, in this example, the first array is 0 in here, but the last element is 1. But in circular array, there's no first and end because the tail and head is connected. So next of the 1, it becomes 0. So then how can we get the subarray in here? So for example, the 0 minus 1, 5, 0 minus 1, 5, those three elements can be one of subarray, and it can be represented in normal array like below. And next, we can get the 1, 0, minus 1 as also as a subarray, but it can be represented like below in this normal array. So you can see there's a split. Those elements were split in this normal array. Then, how can you get the maximum sum in subarray? If you're familiar to get this problem, you definitely know the cadence algorithm. Though, what is a cadence algorithm? Cadence algorithm can be used to get the maximum subarray sum problem in normal problem. If you know the cadence algorithm, you can skip this explanation after this slide. Okay, so if you don't know cadence algorithm, I'm here to help you what that algorithm is. So before we start, we have two variables, which is max ending here and max so far. So max ending here variable means that current sum of subarray from each element's index. It means that if you are in 0, the max ending here becomes 0 because there's only one element in here, 0, right? And the max so far variable means that the maximum sum value so far. So starting with int mean, which is the smallest number represented as an integer. So now we have two variables, and starting from 0, we're gonna go through all elements, and it becomes the time complexity, linear time complexity. So from starting here, we're gonna add those value to the max ending here. So in here, the max ending here becomes 0 here, right? And we're gonna check two conditions. So if max ending here is bigger than max so far, we're gonna update the max so far into the max ending here. And the max ending here is smaller than 0. It means that there is definitely a negative integer which makes more smaller sum. So I'm gonna update max ending here is equal to 0. So first, because max ending here, the value is 0, and because it is bigger than max so far, so we're gonna update the max so far as the 0. And also the max ending here, because it is not smaller than 0, so it is same as 0, right? And next, the max ending here's value becomes -1 because we keep adding the value into max ending here. So 0 plus -1 is -1, so it becomes -1 in max ending here. And we're gonna check the second condition, max ending here is smaller than 0 or not. And you can see the max ending here becomes -1, so I'll update max ending here to 0 again, because the -1 makes the maximum sum to more smaller, so I'm gonna just ignoring those elements in this place. And let's go to the next element. So in 5, the max ending here's value becomes 5 because the before max ending here became 0, so 0 plus 5 is 5. And we're gonna check the first condition, max ending here is bigger than max so far, because 5 is bigger than 0, so max so far becomes max ending here, so it becomes 5. And because max ending here is not smaller than 0, so let's just keep that. And -3, it becomes 2, -3, -5 minus 3 is 2, so and it is smaller than max so far, so I just skip this level. And in 5 it becomes 7, 2 plus 5, because it's bigger than max so far, so updates max so far as to 7. As in this way, we're gonna go through all elements like that. And 1 because bigger than 7, so it becomes 8. So end of this algorithm, we can get the answer as 8, and the subarray is from 5 to 1. If you're using the cadence algorithm, you can get the maximum subarray value in linear time complexity. Alright, then what about the maximum sum in circular subarray, which the real problem wants? So, as we see, we can find out there are two cases. As you see, if the maximum subarray exists and it is in the middle of the array, as you see before example in here, you can get this answer from cadence algorithm. So it is easier one than the second one. Then what is the second case? The second case is a split case that, for example, we have A, B, C, D, E, F, G array in here, but those subarray A, B, and F, G, F, G, A, B, those subarray is the maximum subarray. In this case, you cannot use cadence algorithm because those elements are split, so you cannot get the original cadence algorithm. Then how we can get those maximum subarray? All right, then let's take a closer look at the problem. First, what I want to get is the maximum sum of A, B, F, G. We can represent this maximum sum as S1, and the total sum of this array can be represented as 0, which is total sum of A, B, C, D, E, F, G, the whole elements in this array. Then I can use the S2 as the sum of C, D, E, which is the rest of the elements except the elements of the maximum sum. And then we can say that S0 is S1 plus S2 because the S0 is a total sum. So S1 plus S2 becomes S0, right? And we just assume that the S1 is maximum sum. Well, then what becomes the S2? S2 becomes the minimum of sum array, because if the S2 is not minimum sum array, and the S1 cannot be maximum sum, because the S1 is S1 consists of the elements which makes maximum value of in this array. So automatically the rest of the elements of the sum can be just minimum. And if we know that the theorem, we can get the S1 as S0 minus S2, which is the total sum minus minimum sum of the rest elements. In this way, we can use the cadence algorithm, which is the minimum version, because the original cadence algorithm is getting maximum sum of subarray, but this version is the getting the minimum subarray of sum, right? All right, let's go dive into the code. From the start, we need variable with total sum first, and I need max in here and max so far, which is initialized with int mean, and I need, because we have to get the minimum subarray as well, so I need the mean ending here and mean so far as well. We just starting with integer max, and from start to the end, I'm gonna add the all number to the total sum, and max ending here is gonna be the maximum value with max between maximum ending here plus num and the num, and max so far would be the maximum value between max so far itself and the maximum ending here. So if the maximum ending here is bigger than the current max so far, it updates to this value, and mean ending here is also getting minimum value. Mean ending here plus num and the num itself, and mean so far becomes minimum value in mean so far, minimum ending here. And after this loop, we can get the total sum and the max so far and the min so far, which is the minimum sum from circular subarray. I'm not the circular subarray. It is just it is just array. So after we do that, we have to check the maximum max so far value is bigger than 0 or not, because the arrays consists of only the negative integer like 2, -2, or -3, -1, like that. The maximum so far value becomes always negative. So in this case, you have to in this case, the maximum subarray becomes always the biggest value in this array. For example, in this case, it's -1. So if it is smaller than 0, I'm gonna return just max so far, and if it is not, I'm gonna just return the maximum value between max so far, which is the first case that I explained in this slide, and the total sum minus min so far, which is the second case in the slides. So I calculate those two cases in the same time and compare those two value in the last. So the bigger value becomes the answer. So after that, min so far, max so far. So I'm gonna submit this answer, and all right, we got the answer. Okay, so thanks for watching this video, and see you in the next video. Bye.